In the last segment, we set up a limiting reactant problem that you see on page 18. You see that when you have two specific amounts of two specific reactants, you know you're going to have two stoichiometry problems. So I set it up for you with the starting place and the ending places and gave you the plan. You were to pause the video, fill it in, and now we're going to come back and see what our answer is and what our interpretation is. Grams will cancel, moles will cancel, moles will cancel, and if only bromine matters, we would expect 151 grams of ammonium bromide. Grams will cancel, moles will cancel, moles will cancel, and if only ammonia mattered, we would get 390 with a decimal, 3 sig figs. We would expect this much. Our maximum yield is 151 because our interpretation is once we make 151 grams of ammonium bromide, our Br2 runs out. So don't forget to actually answer the question. Maximum yield is the same as saying theoretical yield is going to be 151 grams of ammonium bromide. Limiting reactant is going to be the Br2, which means the excess reactant is ammonia. Okay? Second problem, we would set up the same way. Okay? This one, however, is a new reaction. So you would have to actually write the equation. N2, H2, NH3. So I might ask you type, in which this is a combo. I might ask you to balance and give me the sum of the stoichiometric coefficients in the balanced equation, which would be 6. Then I might ask you a variety of other questions. I might ask you what's the molar mass of this. I might ask you the molar mass of this. I would ask you a bunch of questions. Again, this is what you're going to want to expect to see on your exam. One equation and a bunch of questions. Nonetheless, for this example, we know this is limiting reactant because we have specific amounts of both ingredients. So we have two starting places. We have 156 grams of N2 as one possibility. In both situations, we want to know how much ammonia. Well, that's usually code for grams, so we're going to solve for grams. The second starting place is 112 grams of H2. And again, we're going to solve for grams of ammonia. Either way, we have to make a plan. Start with A, end in B, always means mole ratio. So we're going to go grams of N2 to moles of N2 to moles of ammonia to grams of ammonia. Molar mass, mole ratio, molar mass. Okay? Same thing down here. Grams of H2 to moles of H2 to moles of NH3 to grams of NH3. Okay, so our process is the same. Every time I do this, I'm using the same process. I'm just adding to the complexity. So you can see that we could start with atoms or we could end with atoms, and that means in our plan we would need Avogadro's number. Okay? Nonetheless, molar mass of N2 is 28.0 grams per mole. Molar mass of NH3 is 17.0 grams per mole. Okay, so you would add these up for the purposes of our flipped video. I need to keep it at 10 minutes. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, 28.0 grams of N2, 1 mole N2, 1 mole N2, 2 mole NH3, 1 mole, NH3, 17.0 grams, NH3. Okay, and if only the N2 mattered, we would expect 189 grams of ammonia. We'll do the same thing here. 2.0 grams H2, 1 mole H2, 3 moles H2, okay, 2 mole NH3, 17.0 grams NH3, 1 mole NH3. Okay, make sure your units cancel. Your canceling unit is always your best friend. Okay, so if only the H2 mattered, your calculator is going to tell you 635, but because we have 2 sig figs here, we're going to call that 640. Either way, it doesn't matter because this is the maximum amount we can make. And once we make 189 grams of ammonia, N2 runs out. Okay, so be sure to answer the question. How much ammonia can be made? 189 grams. That's question number 1. Question number 2, which reactant is in excess? Well, the N2 is going to limit, so the H2 is in excess. So you see how much easier your life is when you are being told which one is in excess and you don't have to figure it out on your own. Okay? Okay, one last one. I'll set it up for you, and then as we did before, you can finish it up. CH3 combusts. Well, okay, so now you have to write an equation. C3H8, O2, CO2, H2O, 3 of these, 4 of these, 6 plus 4 more is 10, so we need 5 O2s. Okay, so again, I might ask a list of questions. Okay, what type is this? Where is the heat? Is it absorbed? Is it given off? What's the mole ratios? What's the sum of the stoichiometric coefficients? Okay, so please be thinking of that. Okay, we know this is going to be limiting reactant because we have specific amounts of both ingredients. So 90.3 grams C3H8. What mass of water vapor? Grams of H2O. That's the same as saying maximum yield, theoretical yield, however it is you want to say it. It's all saying the same thing. Okay? Down here, we're going to start with 110.1 grams of O2. We're going to end with grams of water. Okay? So pause the video, okay? Make a plan, check your answers, and when we come back, we'll check our answers here and we'll go to the last topic in this unit.